lab, you will observe deposits of solid copper form on a strip of zinc as the copper ions in solution are reduced by the electrons that are products of the oxidation of the zinc metal.
Hey you.
Who, me?
Yeah, you. Are you not particularly science-minded? Are you easily confused?
Yeah.
Don't you worry. You can still succeed in lab.
Gee whiz.
You don't even have to crack open a textbook. That kind of hard work and effort is completely unnecessary. With these techniques of manipulation, you'll learn how to acquire a smart lab partner and exploit their intelligence for your personal gain. It's foolproof.
Oh, swag.
First, you must uncover the best student in the room as the object of your exploitation. Use your time in class wisely. While your teacher drones on about oxidation reduction reactions, study your peers instead of wasting the period learning the information. Narrow your search by focusing on those eager students who sit in the first 2 rows of desks. Examine them carefully. Note every suppressed yawn, the slightest head nod, the faintest flicker of a smile on their lips. Pay close attention to the questions they ask. Hey, let's watch as this student poses a question.
Is it possible that the Lewis structure for the ammonium ion could be this instead, so that the electron pairs are oriented even farther apart?
Wow, now that's a question, laced with complexity and intense vocabulary. Now let's watch another.
So, are the molecular orbital theory and the valence electron pair repulsion theory basically the same way to find Lewis structures?
Don't fall for these students who try to sound smart but end up asking questions without understanding what they're saying.
That's a stupid question.
Now that you've identified the smartest chemistry student in the class, begin your campaign for their lab partnership. Elbow past your classmates and position yourself just behind your target, and read off a few of the complicated sounding steps. Convey through your tone of voice that while these steps may seem complex, you understand perfectly.
Of course, the zinc is simply the reducing agent and itself is oxidized. It makes perfect sense now.
Don't you just love oxidation reduction reactions?
Next, convince your prospective lab partner that there is some greater principle involved in the experiment that she didn't realize. For this purpose, memorize some complicated sounding phrases from physics and calculus.
What? Oh, okay. The derivative of the solubility versus temperature graph implies that the buoyant force exerted on the molecules in the solution exhibits negative concavity and therefore can always account for the isotropic nature of the force per unit area pushing against these particles. What does that mean?
Nothing. But it certainly sounds meaningful enough to inspire your subject with admiration and trust.
Wow, what an interesting point.
Once you've captured her attention, flash a meaningful expression, maybe an impatient sort of glance around at your other classmates, and a subtle eye roll, a face that says, "Those poor fools, they have no idea what they're doing." At this point, offer a kind smile.
Do you have a partner?
Well...
Once she accepts your offer, you must be careful to do nothing while appearing to do the bulk of the work. If she asks you a question, scribble in your notebook. Stick with unintelligible combinations of numbers and equations in case she checks your work. Avoid unicorns. And mutter to yourself. Appear lost in your complicated ideas. This will give her time to figure out her own question.
Do you understand step 4?
I'm sorry, did you say something?
Try not to speak, but if you must, make sure you call the lab equipment and substances by their proper names. Don't refer to the chemicals as ingredients. At the first sign that materials are needed, you are off.
So, what ingredients, chemicals, do we need?
Well, we'll need copper chloride solution and...
Your job for the rest of the lab period is to mask your ignorance by spending your time massing chemicals and stirring solutions and taking temperatures and cleaning out flasks. All the tedious tasks that require no understanding of any underlying concepts. Don't disturb the work of your partner. Most smart people would rather be left in a vacuum of their thoughts, unbothered by the questions and concerns of their inept lab partners.
Isn't this fun?
and so you will oblige her with the peace and quiet that she desires. Your partner will be happy, left to her own devices, to conduct the experiment as she wishes, without having to fill you in on all the minutiae of the lab, believing that you already understand it all. And you will be happy, mindlessly scampering around, familiarizing yourself with the lab equipment, receiving a well-deserved A.